Let's welcome Dr. Peter Lee.
Wow, hello. It's such a pleasure to be here, and let me say on behalf of all of us at Microsoft, it's such an honor to build on our deep partnership with Tsinghua University and bring you today's conference on computing in the 21st century. Really a deep honor for all of us. In today's conference, you're going to hear lectures from some of the most respected and accomplished scholars and researchers in computer science, and people who have accomplished things and contributed to human knowledge in ways that have made a huge kind of impact on all of us. In fact, some of the things that have been accomplished by today's speakers have resulted in innovations and technologies that are in your hands and in your pockets right now, but maybe even more importantly, are behind the scenes, invisible, in the cloud, in our roadways and infrastructures, in our power systems. So much of what has been accomplished in computing over the past 25 and 30 years has resulted in what my boss, Harry Shum, refers to as the invisible revolution. All of the things behind the scenes that just make our lives better, make us all productive, and give us new ways to entertain and educate ourselves. Research is really at the heart of all of those kinds of innovations, and for that reason, research really matters a lot to Microsoft. And so what I wanted to do in this opening lecture for 21CCC is try to give you a little bit of an idea about why research is so important to Microsoft, and at least one point of view about why research matters to innovation and how innovation can be brought to impact to make our lives and our industries better. And so let me just start with something that's very important to Microsoft. Now, Microsoft, of course, has a lot of products. We have a search engine called Bing. We have an entertainment device called Xbox. We have a cloud called Azure. We have many things. But of all of those products, the one that's most important to the core of Microsoft is the Windows operating system. And this summer, we had a very important day when we released to the world a new version of Windows called Windows 10. And that happened in July of this summer. And that, in many ways, is possibly the most important day in the history of Microsoft. And that's saying something because Microsoft, as a company, is over 40 years old. Now, on that day that Windows 10 was released to the world, our CEO, Satya Nadella, actually wasn't in the Microsoft headquarters in Redmond, Washington. Instead, our CEO, Satya Nadella, was actually in Africa, in Kenya, reviewing an initiative that we have in Kenya that closes the digital access divide and uses advanced technologies to bring the internet and new educational and productivity opportunities to millions of people who have had trouble with that access in Africa. And so that was really an important statement by our CEO on such an important day when we were announcing our most important product, that he was in Africa. And it was also a very proud day for me as a person who works in Microsoft Research, because this particular initiative uses a wireless networking technology that we refer to as TV white spaces. And the idea of TV white spaces, I won't go into too many details, but the idea of TV white spaces is to use television frequency bands in order to provide very high bandwidth and long-distance wireless networking access at very low cost. And it's called white spaces because if you look at the way that television frequencies are used in most of the world, it's very dynamic. Exactly which parts of the frequencies are inhabited by signals changes over time. But if you use very clever algorithms and powerful database technologies, you can keep track of where these openings in the television spectrum pop up dynamically, and you can use that in order to transmit access to the internet. And so we were just very, very proud, in addition to launching a new important product called Windows 10, to have one of our research projects at Microsoft Research being highlighted in a review by our CEO in Africa. But we can ask the question, on such an important day for the business of Microsoft, why was our CEO doing this? And that really gets to the fundamental heart of the question that I want to really address today, which is, why do we do research? And why is it important? Now, that is a question that is more important to the world than just Microsoft. Every country in the world today is thinking hard about how to get more innovation. That's a very big discussion in China, and it's a very big discussion in the United States. Last spring, the president of MIT wrote an important editorial in the Washington Post. And in that editorial, he was speaking directly to this question of how do we get more innovation? And the editorial was important because the MIT president, Dr. Rife, actually pointed out that innovation actually comes at its heart from doing research. But the world has been changing. And so in one statement in his editorial, he said, in the past 5 years, the United States has undergone a profound shift in how it develops, adopts, and capitalizes on innovation. And those shifts have prompted a desire to go faster, to have bigger impact, and to get to impact on the real world much faster than we've ever done before. And that has created very difficult pressures. In the United States, traditionally, a lot of the best research has been supported by the US government. But in this new world, the MIT president points out that government is no longer able to effectively supply the kind of long-term funding that leads to the kinds of results that new companies and products need. And so this is a very difficult problem. And very similar problems also exist in China. So how do we think about research, and how do we get the most out of the research that we do? Now, that question has gotten so important that in the technology industry today, computer industry, more and more researchers are being hired directly into companies to just do research and think thoughts about how to create new innovative and disruptive futures. 2 years ago, Mark Zuckerberg, who's CEO of Facebook, actually went to one of the premier academic conferences for research in artificial intelligence called NIPS. And he spoke the language of AI researchers, which is very impressive, and announced the creation of a new basic research lab called the Facebook AI Research Lab. Baidu also announced about the same time a new research lab in the Silicon Valley devoted to basic research in artificial intelligence. These labs are new entities that are trying to take foundational research, the basic research of discovery, of pushing the frontiers of human knowledge, in the hopes and in the expectations that the research results are going to lead to new innovations that can be commercialized by these companies like Facebook and Baidu. And of course, they're not the only ones. Amazon in the United States also has been investing in research. They have a research lab called Lab 126 that has been hard at work trying to invent and understand new kinds of device technologies. And they've been having some trouble because they get pushed very hard, and sometimes the innovations that come out are not commercial successes. And that leads to a lot of reorganizations and a lot of anxieties. And of course, Google also has been investing in research, in Google Research and in Google X. And again, As research labs like this are pushed so hard in order to go faster and produce innovations faster and produce products faster, sometimes the things that get produced aren't completely successful. And there have been some struggles in all of these places. And so we see that at national levels in countries like China and the United States, as well as at the level of individual companies, there's a tremendous faith in the idea that research can lead to new innovations, but also some trouble. We haven't quite unlocked the secret about how to do this. The bottom line is that right now, what we see in our industry and in the world is that research is our best hope for new revolutions and new advances in our industries. And research, especially in machine learning and artificial intelligence, is being looked upon as a driver for a new industrial revolution. And so in today's 21 CCC, we chose the theme of AI as a focal point. But when we say AI, we really mean it in a broad way. It is not just the idea of intelligent agents and machines that can see and hear and understand like people do, but also all of the computing infrastructure in databases, in networks, in human-computer interfaces, and really the broad spectrum of computing research that ends up being incredibly important in pulling all of this together in a way that is going to lead to some value. And so what I'd like to do is just give a high-level picture of how we approach this within Microsoft. Microsoft has invested in research for almost 25 years, founding 24 years ago the Microsoft Research Organization, which today now is over 1,200 researchers and engineers spread out over a dozen labs around the world. Our largest lab outside of the United States being here in Beijing. And so what I'd like to do is take a concrete example and show how we approach doing foundational research, the nature of that research, and how we try to extract value for Microsoft and for the world out of that research. So let me start with machine learning. Now, the first thing to do is just to give a picture of what machine learning is about is we can imagine a machine learning system. A machine learning system is some kind of system that is able to learn from experience. And today, we can think of experience as data. So we want a system that can look at lots and lots of data and produce answers or programs that accomplish some task. So for example, we can have a machine learning system that accepts lots of speech input. Maybe it's speech input of someone speaking in English. Maybe it's data sets of many, many different people speaking English, all labeled with what they're saying. And when we take that speech plus the labels, the transcripts of what the speech means, we call that training data. And so if we have an appropriately developed machine learning system, we can take our English training data and feed it to the machine learning system and produce an output, which is a piece of software. Sometimes we call it a model, a trained model. And that model then can run, hopefully on a small device, like a smartphone, so that it accepts speech input and produces a transcript of the speech, possibly with some errors. And so this is the general schematic of how one might use machine learning to create a system that can understand human speech. Now, one of the amazing things that's happened just in the last 5 years is that we've unlocked some secrets in our research on how to build machine learning systems that have the property that if we provide more data, and that data might require very large amounts of computational power to process, that as we feed more data into a machine learning system, the capabilities of the speech recognition system improve. So in other words, the more training data we provide to the machine learning system, the fewer errors our speech recognition system produces. And that revolution has made it possible to create the technology that probably is in all of your pockets if you have a smartphone. If you have a smartphone now, you have speech interfaces that are remarkably better than they were just 5 years ago. And they're better 5 years ago because of advances in machine learning. But these advances go further than that. We can take that system that's been trained on English and we can give it Mandarin training data. And when we train that on Mandarin data, we get a system that understands both English and Chinese speech, generating either English words or Mandarin words. And remarkably, even though we have trained this English system on Mandarin only, that training on Mandarin improves the English performance. And then if we take the system and train it on French, the Mandarin improves and the English improves. And so we get what's called the transfer learning effect. And that transfer learning effect has been another thing that's been absolutely remarkable advancement in our basic research in machine learning that has led to just remarkable advances in the practical application of speech recognition systems. This graph shows the result of this. This is a graph that shows the progress in the accuracy of speech recognition systems from 1993 to just a few years ago. And so on the x-axis, you see the year-by-year test of the best systems in the research world. And on the y-axis is what's called the word error rate. And so the word error rate is basically, you can think of like this. If you were to all try to write down what I'm speaking right now, and then later we check how many errors you've made, how many words you've mistranscribed, that would be the word error rate. And so if you look at this graph, you can see at the beginning in 1993, the best speech recognition systems basically didn't work. They had nearly 100% error rates for open domain speech. But because of the application of machine learning, over a period of about a decade, up until about 2000, there was very rapid improvement to the point where in about the year 2000, the best speech recognition systems at Microsoft Research and at universities were achieving word error rates of about 26%. You can think of that as getting one word wrong out of every 4 spoken. And now you'll see that there was a long period where there was no discernible improvement, and I'll say something more about that later. There was a lot of intensive research during that period from 2000 to 2010. And then suddenly, we passed a tipping point, and around 2010, there was again a major advancement in machine learning in the application of very, very large data and computational power using something called deep neural nets to create another major improvement, where now today, in the laboratory, several research groups at Microsoft Research and other university and company laboratories are in laboratory conditions achieving word error rates of under 7%. Probably better than any of you can do in real time. And that's just an amazing achievement. So machine learning has just absolutely transformed how we're able to have a computer hear and understand human speech. That blue sky kind of thinking, that curiosity-driven work to just understand what processes, algorithmic or cognitive, are involved in understanding human speech have really resulted in these advances in our understanding of machine learning systems and algorithms and have led to these kinds of improvements. Those improvements were very important to us in Microsoft Research, so important that some of you might be aware that 4 years ago in this very conference in Tianjin, China at 21CCC, the founder of Microsoft Research, Rick Rashid, was on stage and for about 5 minutes used an advanced speech recognition system to speak in English, but have his speech come out of these speaker systems in Mandarin in real time. I was there in 2011, sitting in a seat right about there, and I just remember how shocked the audience was. I was sitting actually near some of our researchers who were working on the system, and they were very scared, not knowing if the system was actually going to work for the founder, but luckily it did. I remember looking for several further rows back and seeing students actually with tears in their eyes, being able to see the magic of someone speaking across the language barrier. Just to give you an idea of just how magical that is, what I'd like to show you is a video demonstration of the power of that kind of simultaneous translation system. And this is a video demonstration that was recorded at just about the time that this demonstration in Tianjin, China was made. Hello.
你好，
I'm really pleased to have this opportunity
我很高兴有这个机会
to show you a little bit about what goes on in our research labs.
给你说说发生在我们的研究实验室。
As you can see, even though I don't speak a second language,
如果你能看到你，即使我不说第二种语言，
I'm speaking to you now in Chinese in my own voice.
我说话，你知道的，中国用自己的声音，
It's pretty cool.
这很酷。
This is all made possible because of the advances in big data and machine learning.
因为在大数据和机器学习的进步，这都是可能的。
The same advances we've been talking about today.
我们一直在谈今天同样的进展。
And while the system isn't perfect,
虽然系统并非完美，
in fact, you can see it's making a few mistakes.
事实上，你可以看到它让几个错误，
The rate of improvement has been rapid.
发展速度很快。
We think it will be practical soon.
我们认为这将很快实用。
We believe the underlying technologies will change the world.
我们认为，基础技术将改变世界，
They will help you become more productive,
它们会帮助你提高生产力，
and they will help you connect with people around the world.
它们会帮助你与世界各地的人联系。
At Microsoft, we dream of a world where language no longer separates us.
在微软，我们的理想世界里，语言不再把我们分开，
but instead brings us closer together.
而是让我们一起更近。
We look forward to all of you joining us in this exciting dream.
我们期待你加入我们在这激动人心的梦想。
Thank you.
谢谢。
By the way, it's always a little bit scary to give that kind of demonstration in front of a crowd that actually understands Mandarin. I am aware of some of the mistakes that were made by the system, and I could hear some chuckles. But there's still sort of a magic here. And actually, one of the things I find so wonderful about computing research is that we can start from really foundational, basic blue sky research, just trying to understand the structure of human speech, trying to codify it in a machine learning system, just really understanding it at its foundations, understanding it algorithmically, understanding it mathematically. But then in computing research, what's so wonderful is we can take that understanding, once we believe we have some understanding, and turn it into some kind of technology. We can invent something and actually write programs and build machines that actually codify that understanding. We can create new phenomena. And that's a shift of what I call the shift from blue sky research to inventive or disruptive research. I can't think of any other field of endeavor of scientific research where we have such an amazing ability to easily shift during our research endeavors from kind of blue sky thinking to inventive or disruptive thinking. It's just such a wonderful thing. And when people try to understand why computing research is so important to the concept of innovation, I think this is one of the keys. And then, of course, working at Microsoft Research, what is even doubly exciting about that is that sometimes when we invent things, we have the opportunity to deploy those inventions to the world. We can join with product engineering groups and business people in a big company like Microsoft and try to deliver brand new services and products that really enable people. We can start to realize the dream, in this case, of eliminating the language barrier between all internet-connected people. And so one of the things that's so exciting is that just last month, our Skype product for Windows now has speech-to-speech translation as a built-in feature. And while that's for Windows today, over the next few months, we'll be rolling this out for other platforms, for iOS and Android and the like. Already, we see with speech-to-speech translation in Skype, the amazing ability of grandchildren being able to talk for the first time to grandparents that live in a different country and speak a different language. Or we're able to, for the first time, see people working in some kind of NGO in Nicaragua, speaking only Spanish, conducting business productively with people in New York City. Or, because of the facility of speech recognition, we now have, in Microsoft Research itself, husbands and wives, where the husband may be hard of hearing, may be deaf, being able to converse through Skype with their wives in a much more seamless way. And so it's just been absolutely magical to see this shift now from blue sky research to inventive or disruptive research to mission-focused research and deploying this to the world. And the challenge is the research doesn't stop, because to bring something like this to hundreds of millions of users of Skype is not just an AI challenge, but it is a massive database challenge, it's a massive distributed systems challenge, it's a massive software engineering challenge. And all of those things just hatch new basic research questions and problems that we work on now every day. And it's, of course, not just Skype, but now, in fact, all of our mobile applications are increasingly becoming voice and speech enabled through the same sorts of advances. Now, I wanted to get back to this and point out something that's very important. Now, Skype Translator was released in Skype for Windows just last month. And you might think that that's very fast, because we made a demonstration for the first time in China of the speech-to-speech technology just in 2011. And so only 4 years later, we have a product that seems pretty fast, and it is fast. We worked very hard. But the fundamental research that enabled this stretches back decades. And in fact, I just wanted to highlight this long period of about 10 years when we were very hard at work in Microsoft Research and in many universities around the world, trying to understand the structure of human speech, and yet, for that long period of 10 years, not seeing any practical improvement in deployed speech recognition systems. And this is a fundamental characteristic of research, and one of the reasons why investments in research over the long term are so important and why it's so challenging. Because every day during this long period, we were actually learning new lessons. We were doing research around the world. And yet it took the accumulation of a decade of lessons and insights and maybe some luck before suddenly we pass a tipping point and have a rush of new practical improvements. And so the point there is that research is a long game. And for countries and societies that aspire to be leaders in innovation, the supporting infrastructure, the governments and the agencies that are tasked with sparking innovation and supporting research must understand that it requires patience and longevity and stamina in order to realize the benefits. Now, another thing to say about research is that when you work on something as fundamental as machine learning as a fundamental idea spans much, much more than just speech recognition. It's a very general concept. And so if you use the Bing search engine, you are actually using a machine learning system, because the Bing search engine is reading all the documents on the World Wide Web, reading all the queries that you type in, looking at what you click on in response to those queries, in order to learn the structure of the World Wide Web. And it's doing that using machine learning algorithms that are strikingly similar to the machine learning algorithms in something like Skype Translator. Yesterday, we launched an important new video game called Halo 5. And if you play Halo 5 and you want to find a game on the network with other people who play like you do, we use machine learning to observe your style of play and match you up with people that you are very likely to have the most fun with. Again, that's machine learning. We have new devices like the Microsoft Band. And the Microsoft Band is able to track my heart rate, the number of calories that I'm expending, and the amount of oxygen that I'm taking in. And it's doing that amazing amount of stuff with just a little bit of sensing, again, using machine learning algorithms. And for companies who are big customers of ours, we have been using machine learning to study the documents within a corporation's network and emails and meeting schedules in order to figure out the most relevant documents and people and tasks for each worker in these companies, and that's all done through machine learning. So machine learning just has this kind of broad ability to augment human intelligence and give all of us the capacity to do much more. I don't know how many of you recognize this passage. It's a very, very strange passage. But in case you don't know what it is, this is the passage that you must type in on your smartphone if you want a chance to claim the Guinness World Record for text messaging speed. And so, very kind of surprisingly, the machine learning algorithms that we use for speech recognition can be adapted very simply to allow you to, on your smartphone, have a new method of swiping text input that allows much, much faster text input. And so we adapted our speech recognition machine learning systems to the problem of text input on smartphones in order to capture the Guinness World Record for text messaging speed. And so what I'd like to show you now is a short video of the world record attempt. Here it goes.
1, 2, 3, go.
Done.
Yeah, looks. We're just gonna check the text in.
Congratulations.
Congratulations.
Thank you.
After the lecture, Dr. Baining Guo will demonstrate his ability to capture the world record for anyone who asks. The point there is the surprising and unplanned, really unanticipated outcomes of research. Just speaking personally as a researcher, they are the most fun. They're the ones that get me excited about research. But also, as a practical matter, they are oftentimes the most valuable results from research. And the reason they are often so valuable is that the unanticipated or unplanned outcomes of research are oftentimes the ones that can surprise or disrupt others. When you create something that's kind of wasn't intended, that was surprising, you have the chance for doing something disruptive. And so another thing that is very challenging for countries and societies that are looking to research as a driver of innovation is that there's a tremendous urge by company leaders, by government leaders, to want to plan research and to say, we are going to fund research for a specific outcome, and then to be completely blind to any other possibilities. And while that can sometimes work, it can also create the danger that you miss maybe even more important spin-off effects from research. And so research requires a kind of open-mindedness to kind of unanticipated outcomes. And this was absolutely true in all of the research that we tried to drive in Microsoft Research. I mentioned about the Skype translator, And of course, we had the plan, directed by our CEO, Satya Nadella, to put our speech-to-speech technology into Skype. And we have been accomplishing that plan very successfully with a lot of hard work. But a lot of unintended outcomes have happened as well. And those unintended outcomes lead us to a fourth type of research, which I call sustaining research. This is a photograph of a research meeting in our labs. And I want you to just imagine in your head what kind of noise is going on in this meeting. This is a meeting where people are laughing, they're talking over each other, they're interrupting each other, there's a lot of back and forth. And if you think about the kind of speech there, it's a kind of speech that's very colloquial, very friendly, I would say even intimate. And this is important because when we worked on the Skype translator, one of the things we discovered is that our speech processing systems, our models for speech and for translation, didn't work too well. And now, what was the problem? Why didn't they work well? Well, as it turns out, most of our speech systems and our translation systems, and this is true for our competitor companies and most universities, have been trained on lectures, on speeches, on testimony from the United Nations. They've been optimized to understand the speech between strangers conducting very short business transactions, like a person speaking to a hotel clerk, or to a taxi driver, or to a waiter, in typical travel scenarios. But if you think about Skype, you have two people talking to each other who are oftentimes very, very close to each other. They're coworkers that are working together across some language divide, trying to accomplish something or negotiate something. It's a granddaughter talking to a grandmother. It's a kind of intimacy that actually deeply affects the speech modeling and the translation modeling. And so what we've had to do in understanding this and doing the research on speech-to-speech translation for Skype is really retrain all of our speech and translation models to account for this highly conversational, intimate interaction. And the payoff for doing that is not only having a system like Skype Translator, but now having new language processing models that give us a chance to actually capture even the kind of speech that goes on in a meeting like this. And for a company like Microsoft, this can have gigantic commercial value because a huge part of our business is actually enabling businesses and companies have more productive meetings and more productive office workers. And so the sky's the limit now that we've accomplished this. And many of you here are probably familiar with the chatbot Xiaowai's. And at the close of today, Xiao and Han will say much more about this. But Xiaowai's is another realization of the lessons that we learn from these systems that give us a way to converse and interact with people in a way that is just much friendlier, much more personable, much more intimate. And so we're just learning so much about how to make our interfaces much more human. And so when you look at these modes of research, we start from blue sky research. That blue sky research might span decades. But every once in a while, we're able to take our learnings and invent something that could be disruptive, like a speech-to-speech translation system. And then if we're very lucky and we work hard, we might have an opportunity in a company like Microsoft to productize this into a system like Skype Translator by engaging in a mission-focused way with product engineering groups. And then the research doesn't stop there, but in fact, there are always unanticipated, unintended outcomes where we're constantly wanting to improve our understanding and improve the technology, but also finding new applications that lead to new insights, that lead to new opportunities for blue sky research. And so in the Microsoft research management approach, we think of this as an innovation pipeline, that we always want to make sure that throughout our research labs, we have very good activities going on at all four stages of this innovation pipeline. And in terms of our investment strategy, we plot this out in a two-dimensional investment map, where on the x-axis we have investments in research efforts that are on a schedule, either a short or long-term schedule. And as we go out on the x-axis, we have investments in research projects that are more open-ended in terms of timing. And on the y-axis, we have investments in research that maybe are in response to a problem that is given to us, perhaps by the company or some product team, or maybe by society. And as we move up the y-axis, we have investments to solve research problems that are much more open-ended, the open-ended search for truth and deeper understanding and sometimes beauty. And to explain this then to our shareholders and to our CEO, we put names on these quadrants, where in the lower left quadrant we have our mission-focused research. In the upper left quadrant, we have our disruptive or inventive research. And then in the upper right quadrant, blue sky research and sustaining research in the lower right. Or, to put it more succinctly, we have a mandate to be smart, be fast, be responsive, and be the best at everything that we do. And so all of the leaders in Microsoft Research are obligated to understand how their investment strategy will lead to impact across these four quadrants. And ultimately to give me great things to brag about and deliver to the world in all four quadrants. Now, I concentrated on one AI problem, which was language processing and translation, but I could have given exactly the same story in a whole range of other areas, in video processing, in digital access, in image processing and deep neural nets, in computer architecture, in software verification validation, in databases. The list just goes on and on. The possibilities are just tremendous. The basic point is that no matter what the field of endeavor in computing research, that research idea plays a central role in all stages of this innovation pipeline, from blue sky research to inventive research to mission-focused research, all the way to sustaining research. And at least in the way that we think of deriving innovation and impact out of the research activities in Microsoft Research and in our collaborations with great universities like Tsinghua, we try to think about how we can hit all four stages of this pipeline. I'd like to close by saying that throughout the day today, we are hoping that many of you will be inspired to think about the possibility of pursuing careers in research. One thing to say is that it may appear as though we have solved all of the world's problems already, and that it's just too hard to get involved and make your own advances. But in fact, we have just barely scratched the surface. The computing revolution has just barely begun. There is so much more to do, and if anything, we need brilliant new people entering the field now more than ever to have any chance to advance our understanding of the research, turn those research results into innovations, and then maximize the impact of those innovations to, as our CEO likes to say, empower every person on the planet to achieve more. So I hope some of you are so inspired. Thank you all for listening.